Okay, perfect. Hey everybody, this is Alex Merced and welcome to the first Data Lakehouse lunch for 2025. And again, these are just regular events where we have topics about the Data Lakehouse. And always appreciate that you guys come check it out. You can also check out the this is a series of events as organized as part of the Data Lakehouse Hub, which you can check out at the Data Lakehouse or datalakehoushub.com, where you can find the blog and a link to the meetup group to be informed on all these events. Okay, and with no further ado, again, today we're going to be talking about why Dremio is the best SQL engine for Iceberg. Okay, so that's going to be our topic for today, why Dremio is the best SQL engine for Iceberg. Now, first, let's just start off by introducing myself. My name is Alex Merced. I'm a senior technical evangelist for Dremio. So I do work for Dremio. I am also a co-author of Apache Iceberg, the definitive guide. I do spend a lot of time thinking and talking about Apache Iceberg, whether it's speaking at different events across the country, speaking at virtual events like these, writing blogs, books, creating tutorials. Basically, I spend a lot of time thinking about the data lakehouse and in particular Apache Iceberg as part of my role as a senior technical evangelist for Dremio. And on that note, as I mentioned, I am the co-author of Apache Iceberg, the definitive guide, which you can download for free by scanning this QR code. So this QR code will take you to where you can download a free copy, a full copy of the book as a PDF. Okay, and again, all links will also then I'll be make them available again at the end of the presentation, and as well on the posting on YouTube afterwards, on the Data Lakehouse Hub YouTube channel. Okay. Now, as well, recently I did a 10-session Apache Iceberg crash course that kind of goes over Apache Iceberg from head to toe, including hands-on exercises, conceptual stuff. If you want to basically check out that course, you can scan this QR code here, and that'll take you straight to the course where you can start basically taking the lessons, doing the hands-on exercises, the whole deal. And last sort of QR code I will put out there is we also do, if you're learning all this material, why not have a credential for it? And Dremio has issued a Dremio verified Lakehouse Associate badge that you can get for completing a lot of this coursework. And if you're interested in kind of adding that credential to your list of credentials, you can scan this QR code and that'll take you to university.dremio.com where you can get that Dremio verified Lakehouse Associate badge. And we've also introduced a few other badges that you can get completing the coursework over there at university.dremio.com. I am the host of several podcasts. Those you can find on your favorite podcast catcher, so I'll let you guys find those there. You can always just literally find everything at my website, alexmerced.com. But with that, again, the topic today is why is Dremio the best SQL engine for Apache Iceberg? But first we need to understand what these pieces are. Like, what is Iceberg? What is Dremio? And to really understand those things, we need to understand what is a lakehouse, because they're both tools that help you better execute lakehouse architecture. So let's just talk about what that is first. So bottom line, when you think about traditional data systems, what would happen is we would traditionally use sort of two main systems to store our structured data. Okay, databases and data warehouses. And these are wonderful tools. They would abstract many things that we don't want to deal with on a daily basis. As far as, for example, like how is the data stored? Okay, when I create a table in Postgres or Snowflake, the data is stored somewhere. I don't have to worry about those details. I just know my data is there. Now, how does the system know that this data over here is, the sales table and this data over here is the orders table? Well, I don't have to worry about that. The system knows what table is what because it has a sort of built-in table format that allows you to say, hey, this data here belongs to this table, and so forth. So again, this is not something I think about when I use a traditional data system. On top of it, how does it know how many different tables exist? Like, how does it know that there's a sales table, an orders table, a customers table, all these different tables that I can just access to without really thinking about it and just write them in my SQL queries? Well, that's because built into the platform is a catalog, something that tracks the listing of tables. And then lastly, with these three things, I now can recognize my data. My data is stored, it's recognized as different individual units, and I can track how many of those individual units or tables I have. But at the end of the day, really what I want to do is do analytics or run queries against that data. So I need some sort of processing layer. Okay, and again, if you're using Postgres or Snowflake or any other database or data warehouse, All of this is built in. So basically, there's also built into the software is a way for me to write a SQL query that gets parsed, then turns into a query plan, and then that query plan gets executed. And the beauty of it is I just don't have to think about any of this. All I know is that if I go spin up a Postgres instance and I write some SQL, I can create data, I can read data, I can update that data, I can delete that data, and ask the questions that I want. Or if I go spin up a Snowflake account, I can do the same. And whether we're talking about databases that typically store the data in a more row-based format, or if we're talking about data warehouses that generally store the data in a more columnar format, better for analytic type queries. Now, this is all fun and good. The problem is, while this makes life really easy because you have all these layers abstracted into one tool, there's a couple downsides. One, each tool does it differently. Okay, so let's say I'm using multiple data warehouses. Not because I need multiple data warehouses, but maybe because it's a big company and there's different departments. Okay, and one department uses Redshift, another department uses Snowflake, another department uses BigQuery. So the problem is they may all need access to the same sales data, the same order data. And what ends up happening is that each team is now making a copy of that data into their preferred tool. So now you're paying for that same real estate many times, and you have potential consistency issues. Okay, or you might end up deploying your own and self-managing your own data warehouse software, or using some sort of managed on-prem deployment, something like a data warehouses of old. And in there, again, you're paying for this thing that's just kind of running 24/7, and you're paying for all the compute that is running that software 24/7. Okay, when you may not be running queries 24/7 on that data, and you're paying for different tools for different teams. So what would be nice is if we could address that issue. Wouldn't it be nice if all of my teams can use their preferred tools, but I don't have to make a copy of that data for every single team, so that way they can work on one sort of consistent set of the data. That, again, solves a cost issue where I'm not paying for multiple copies of my data. It solves a consistency issue where everyone's using the same version of the data, but also it serves a time to insight value in the sense that, hey, if I can work on one copy of the data and we're not spending all this time ETLing that data another time into our data warehouses, then that's less time that it takes me to get my data to that end user, that end analyst, that end data scientists to serve those use cases, which means that AI model can be just a little bit more real time. That dashboard can be a little bit more real time than it would be otherwise. But how do we do that? Only if there was a place where basically all my data exists that could be accessible by multiple tools. Well, that does exist. We have a pattern called a data lake. We use some sort of distributed storage layer, okay, that's just generally accessible. Something like an S3 if we're talking about object storage, or a Hadoop on-prem, and several others like MinIO, Vast Data, Pure Storage. There's endless options here of how to sort of just store all your data. And the cool thing about this is, like, again, since it's storage, any tool can then access that storage, especially through like common APIs like the S3 API and things like that. So you have a storage layer, and then you can use tools to then run queries against that data. So like a Dremio, is very big in running queries against a data lake. AWS has a built-in sort of managed Trino service called AWS Athena, and these things allow you to say, hey, you know what? Instead of moving my data into a data warehouse, I'm just going to go directly to the data sitting in my storage and run queries on it there, whether it's CSV, whether it's JSON, whether it's Parquet. And that works fine. Again, CSV and JSON, as the data gets bigger, may not necessarily be the most performant. So that's why Parquet gets created. But eventually data sets get so big that they don't fit in one Parquet file. So now you may have data sets that are hundreds of thousands of Parquet files. And the problem is that those files don't understand each other. Like I can query the data, but what about updating the data? That becomes more difficult to do consistently with the same kind of guarantees that I get in a database or data warehouse. So there's this sort of, again, there's these layers that are missing. Again, S3 doesn't, a standard S3, and I know there's S3 tables that were recently released that kind of changes this a little bit, but just a standard object storage just doesn't know that, hey, these 100,000 files are a table. It doesn't know what tables exist. It just doesn't look at the files that I've stored in that way. So that limits the ability it doesn't bring the awareness that these tools can have to have the same effectiveness as, let's say, a more integrated solution. So how do you take that to the next level then? Because again, we don't want to have to make those copies in the data warehouse. What we do is we bring those missing layers to the data lake. And that's where you end up with a data lakehouse, where you take that storage layer, you take the compute tools that you're using, but now you add a table format. So now that those 100,000 Parquet files are wrapped in Apache Iceberg or Delta Lake or Hoodie metadata, allowing tools to be able to say, hey, that's a table. Okay, that's not 100,000 Parquet files, that's a sales table. Okay, and that totally changes the way your tools interact with your data. Okay, it becomes more of a data warehouse like feel versus a storage like feel where you're dealing with individual files. And then I can easily know which tables I have available because you have a catalog, something like an Apache Polaris, a Unity catalog, a Gravitino, a Nessie, a Lakekeeper. There's lots of different options, AWS Glue. Okay, and you have some sort of catalog layer that tracks, hey, these are the tables that I have available. Okay, and now with that, you now have those missing layers, and now you can have the same sort of consistency, atomicity, aka the ACID guarantees that you would have in a traditional database or data warehouse, but without having to copy the data into multiple tools. Because nowadays, most tools have built support for reading these table formats like Iceberg. Okay, so now a team that uses Redshift could query those Iceberg tables with their Redshift, or Snowflake can query those Iceberg tables with their Snowflake, or query those Iceberg tables with their BigQuery. Okay, or use other tools like Dremio or AWS Athena instead. So basically, different teams can choose their preferred tools without necessarily having to duplicate the data over and over again. Okay, and again, that also saves time in delivering the data to the end user. That's sort of why this whole Lakehouse thing is such a big deal and why everything's kind of moving in that direction. Okay, and specifically, one of the formats that's really getting a lot of momentum. Like last year, there's just so many different Iceberg-related announcements, so much really big Iceberg news, particularly like Databricks purchasing Tabular, Snowflake beginning the Apache, what's become the Apache Polaris project, BigQuery, adding Iceberg support, AWS creating S3 tables, which are based on Iceberg. All these different features, all built around this one format, Apache Iceberg, really kind of quickly becoming sort of that sort of industry default. Okay, as far as how do I represent my data on the data lake as a table. And essentially, any of these table formats, what they are, is they're a metadata layer. They're essentially saying, okay, hey, I have this metadata that gives the tool, the engine, so Dremio, Redshift, Snowflake, Athena, whatever, gives them the information to understand the table as a table, to understand it as a object, instead of thinking of it as like endless number of files. It gives it just that context so they can access that data more smartly or more intelligently. So generally the way this would work, so if I were to imagine like, hey, a query engine, whatever query engine you're using is going to go query that Iceberg metadata. Okay, this first step it does is it goes and checks the catalog. So you have a catalog that is tracking your different tables. And what you would do is let's say Dremio would go make a request to that catalog and say, hey, catalog, I'm looking for the sales table. Can you tell me where the sales table is? And then it would give you an address on your storage, let's say S3, where the latest version of the metadata is, which is in a file called metadata.json. Every time the table changes, a new metadata.json is created. Okay, so in that case, I want to make sure that I go access the newest one, and that's what the catalog does. The catalog is just basically saying, hey, see if sales table, well, the latest metadata file is v whatever .metadata.json. And that metadata file is a JSON file that has all the high level information, like, hey, what folder is the table in? What is the schema of the table? What is the partitioning of the table? Is there any kind of sorting rules? All sorts of different information that will be relevant at a high level to understand that the table is going to be in that file. Now, once I understand, hey, this is how the table is defined, I need to actually go find the data. So there's another file called a manifest list that represents a particular version of the table. So each manifest list represents one version of the table. Okay? So all those versions are listed in the metadata.json. So I can actually go to that metadata.json and see, hey, here's version 1, 2, 3, 4, and here's the URL, here's the file address for that version of the table. Then in there, it finds stats on groups of files, because each group of files are saved in what's called a manifest. So from the manifest list, I can see, hey, which manifests make up this version of the table, find stats on them, and I can generally eliminate, usually based on partitioning, I can say, hey, these manifests are needed for this query, these manifests aren't. Okay, so right there, I'm already kind of eliminating things I need to scan. Then, once I've done that, which is called partition pruning, I would then go to those individual manifests, which these have the listing of individual files and stats on those files. And then it would say, okay, hey, I don't need this file, I don't need this file, I don't need this file, I don't need this file based on those stats. This would be referred to as min-max filtering. So what you end up with is at the very end, before you've scanned any data files, you end up with a list of just the data files that you really need to scan for this particular query. So you may have a data set that's petabytes big, made up of millions of Parquet files. Okay, but at the end, you maybe only need 1,000 of those Parquet files. Okay, which is a lot less data, which is going to be a lot faster to scan. And using the metadata, you can narrow down that search from 1,000,000 files to 1,000. And then then the engine can go scan those files and execute the query in a much faster way because you've already eliminated a lot of the surface area. And that's how Iceberg, in particular, enables you to have basically data warehouse type speeds when querying your data with different query engines, just at the metadata level alone. As you'll see later on, Dremio adds a lot of other optimizations to get you even faster performance. Part of the theme here, again, Dremio being an engine that's really, really designed specifically to really get you the best value when you're embracing Iceberg. But that begs the question: what is Dremio? So Dremio is a Lakehouse platform at the end of the day. What does that mean? Basically, it's going to give you a variety of different value propositions that make it easier for you to execute Lakehouse architecture. Okay, so let's think of some of the challenges with like Lakehouse architecture. Okay, one, not all of your data is going to be in your data lake. We definitely believe that in a world that you can get to like 80% plus of your data being in your lake, but there'll always be this sort of long tail of other data in other places, whether because of security or compliance reasons, or maybe because they're third-party data that you're getting from someone else. There's going to be this sort of long tail of data that won't just nicely fit into your data lake, in your data lake house. So in that case, you need to be able to connect to that data. So that's where Dremio's unified analytics piece comes into play. Okay, because basically Dremio can connect to many different data sources. So while Dremio really, really provides you lots of value, specifically with working with Iceberg tables on your data lake, Dremio can also go send queries over to your Postgres or MySQL database, SQL Server. It can handle data sets that are on-prem. So if you have on-prem Hadoop clusters, if you have self-managed databases, data warehouses like Snowflake, Redshift, you can connect to all of these things and be able to manage that data all from one place. So it's going to give you that one place where you can see all of your data and fixing that problem. So basically, hey, you can really concentrate on your data lakehouse, but that long tail data is still accessible, still workable with the rest of your data. And also provides you a semantic layer that allows you to model that on top of all of that data in one place. So that way you can have consistent definitions of the data sets that your different teams are using. Okay, so maybe the data set may be using data from multiple sources, but every team will be using the same version of that data set that was curated in the same way, allowing you to have sort of very consistently defined data across your teams. Also, getting into the next bit, Dremio has a really powerful SQL query engine. Again, one of the big focuses of today's presentation that gives you really good performance. And I'll get more deeper into it, but bottom line is because you have that built-in semantic layer and you have features, Dremio already gives you raw performance that's really fast on Iceberg. But two, when you add in a feature that we have that's based on Iceberg called reflections, think of it as sort of like a very souped up abstraction over the concept of like materialized views and BI cubes. What that's going to do is that you move the acceleration that you would oftentimes do in your BI tools, because different teams may be using different BI tools. So one team's using Power BI, another team's using Tableau, another team's using Looker, and all of them are creating extracts in those tools to speed up their BI dashboards. And again, you're paying for that real estate, and you're doing it multiple times, and there's a chance you may end up having the same metrics defined different ways. Instead, you can define those metrics in Dremio semantic layer, use reflections to accelerate them, so that way all three teams, one, are using the same version of the data, and two, getting the same performance boost, without having to create that performance boost 3 times, without having to define that data set 3 times. So again, Dremio eliminates a lot of this repetitive work, so that way you can get the data where you need faster, but also do it in a way that gives your users performance and ease of use. Because at the end of the day, for your end users, they just connect to Dremio and access the data sets they want to use, and they can do that easily through the interfaces they're used to: ODBC, JDBC, REST, Aeroflight. Basically, most of the BI connectors are based on the ODBC and JDBC connectors. So everything kind of works the way they're used to it working with a traditional database or data warehouse. And the last piece is, again, going back to that whole Lakehouse thing. If you are executing an Iceberg data lakehouse, Dremio has many features to help you execute that lakehouse. Because once you have the data in Iceberg or any table format, that data is there, but there's a piece still missing. When you have like a database like Postgres or Snowflake, or a data warehouse like Snowflake, what happens under the hood is that system is continuously optimizing how the data is stored, okay, to maintain performance, or has tools to help you do that depending on the particular tool. But bottom line is, there's stuff to help you sort of maintain it. A data lakehouse, again, you could be using all sorts of different tools depending on your choice. The table format only provides you a standard way to represent your data. You still need to manage like how the data is stored, and optimize it, because over time, as you make updates to the table, it becomes no longer the storage is no longer as optimal as it could be. Especially when you think of like streaming data, where you're adding little bits of data at a time, you're creating lots of small files that would be preferably fewer bigger files. So usually you would have to kind of schedule your own maintenance and set up and orchestrate that, and that can be really difficult. Dremio can take that off your table. With Dremio Catalog, which in our Dremio Cloud product already is GA, and in our software product, our self-deployed, is currently in private preview, Dremio Catalog can handle that for you. It'll track your Iceberg tables, and for the Iceberg tables tracked by Dremio Catalog, it can set up like auto optimization, so you can have those tables just automatically optimized and whatnot. So you get a lot of that benefit as well when you have Dremio. So basically the idea is that your lakehouse just kind of works. A lot of the maintenance doesn't need to be done, because Dremio's going to do it for you. Dremio's going to provide you that acceleration and that sort of standard way of representing your data across your different teams, without necessarily you having to move your data everywhere. And the final big thing about Dremio is that it's hybrid. Again, it can access your cloud and on-prem data sets all from one deployment. So you can deploy Dremio anywhere, whether it's the cloud managed Dremio Cloud, or self-deployed cloud. I could self-deploy on-prem, and that on-prem deployment can access my on-prem data sets and also access my cloud data sets, giving me one place where I can work with all those data sets in a secure way to meet regulatory requirements, to meet internal security needs, things like that. And at the end of the day, again, still providing you an easy access point, easy to use access point that makes things a lot easier for your end users and your data engineers. Cool. So now that we've introduced what Dremio is, again, it's this platform that provides you a query engine, a semantic layer, all on top of a variety of data sources, in particular your data lake, aka allowing you to have a data lakehouse. Let's think about sort of the things that make it particularly good for Apache Iceberg, because there are a lot of different choices you have out there, and I would say probably a lot of choices have not necessarily committed to one path. Like they'll choose, like they'll say, hey, we support Hoodie, Delta Lake, and Iceberg. Okay, again, there's only so many engineering hours, so when you kind of pick a lane and you focus on it, you can create something that's even further added value. And Dremio has certainly sort of made a commitment to Apache Iceberg that really kind of gives you a first-class experience with Iceberg, because Dremio is really committed to that, giving you that top first-class performance on an Iceberg data lakehouse. And one of the ways it does this is through performance. Now, Dremio generally, Iceberg or not, has really fantastic performance. And one of the reasons it has that is for a couple different reasons. In very large part is Apache Arrow. Now, Apache Arrow, many people know as this technology that allows for fast queries. What it is, it's a way to represent the data in memory. So again, if I read a Parquet data file, which is an optimal way to store the data, once I read the data has to be stored in the machine's memory. What's What is the structure of that? That's what Arrow addresses. How do I represent the data in memory in a way that takes up less space, so you use less memory for the same amount of data, and allows you to process that data in a very fast way. And this was actually a technology that in part originated at Dremio. So before it was this open source Apache Arrow project, it was the Dremio in-memory format as part of the Dremio project. And then as it was collaboration and whatnot, it became Apache Arrow. So Dremio has been working with Apache Arrow and Apache Arrow objects pretty much since the beginning. So they have some of the most sort of advanced usage of Arrow that there is in the market, giving you some of the fastest performance on those types of data types in a distributed computing platform, allowing you to scale up as much as you need to. Dremio also leverages Apache Calcite, which also helps in performance. Apache Calcite being a framework that allows you to parse SQL queries and validate, but also allows you to do things like cost-based optimization, do rule-based optimization, basically be able to optimize SQL queries that are submitted, so that way you can execute them in a faster way and get a better execution plan on the other side. So that way, if someone's submitting, not the greatest SQL, they're still going to get good performance because tools like Calcite are under the hood helping optimize those queries. So that's just raw performance. So that's without any kind of cache, without any kind of just basic. Dremio's just really keeps that. And then also, again, Dremio is distributed, so it's able to split up that work among many nodes, so you get really fast raw performance. And a lot of times people just use that. Like at the end of the day, they'll just run raw queries through Dremio, and that satisfies their use cases. Their BI dashboards are fast enough. Their AI/ML training is working fantastic. It's all good. But and that's one. But you can start. One way you can start improving performance even further is adding different caching layers. Okay, and first caching layer I'll talk about is the columnar cloud cache. This is one specific to object storage sources. So if you're using like a data lakehouse, where you're working with like object storage like S3 or MinIO or something like that, what Dremio does is that it'll recognize frequently requested objects, and what it'll do is it'll cache them on the nodes. Okay, and this is going to have sort of two effects. One, you're going to have faster queries because you're not going to have to make as many round trips to your object storage to execute the same query because you already have the object available on the node stored in NVMe memory, so really fast access memory. But two, you don't have to pay the cost of those round trips, okay? Because again, in S3, all of those requests S3, they eventually start adding up into cost. So if you can reduce the number of requests, not only have you sped up my query, but you've also reduced the cost of the query. So Dremio at the same time, everywhere that it saves you performance, it's also saving you costs. Whether it means you don't have to run as big a compute cluster because for the same infrastructure, you can work with more data in Dremio, a large part because of Arrow, or because Dremio is doing caching that doesn't require as much network traffic from your cloud provider. All these things, again, will save you money and increase performance of your queries. Okay, and then more recently added, there's things like a results cache, where basically if you run the same queries over and over again, it can check, hey, has this data been updated, and if not, it can use a cache. And again, a lot of these, I'll get to that when we get to the reflections, but yeah, so that's all really cool. So again, Dremio has all these different ways that it just kind of keeps giving you more and more performance. And on top of that, Dremio's distributed architecture allows you to scale it the way you want. Okay, so in the sense that you can have the size of the actual compute unit you use for any particular engine, and how many different nodes on each engine is up to you. And you can have multiple engines, so you can have multiple clusters of compute running, and you can actually direct traffic to them. Okay, so you can actually create what's called workload management. So you can sit there and say, hey, you know what? I have certain queries that are coming from customers that are not necessarily maybe high priority, so send them to this smaller cluster. But then I have other queries that are from my internal AI/ML training that really need, optimal performance, so send them to this larger cluster. So that way, low priority queries aren't competing for the same infrastructure as high priority queries, and you can set rules for like, hey, when does that compute spin up and spin down? Which queries hit which clusters, all these things, so that way you can make sure you have the scale you need without paying for extra scale you don't need. Cool. Okay, so we've established that there's lots of reasons why Dremio gives you really, really optimal performance. And again, Dremio, a lot of what Dremio does, especially with like data lakes, and this one last piece before I get into the acceleration piece, is when you, because Dremio has always been known as sort of like the fastest query engine for a data lake. So if you're querying like JSON files, CSV files, or Parquet files, generally Dremio's performance is just gonna really, really shine. And part of the reason it does that is because even before everyone was talking about Iceberg and everyone was building Iceberg support, Dremio was already using Iceberg to accelerate those queries. Dremio would create essentially Iceberg metadata around the files that you would on your data lake that would can then leverage to scan your data lake even faster. So Dremio has always been using Iceberg to make your life easier and your life better. Now, there are benefits to when you go natively in Iceberg, and then again, Dremio gives you even more benefits when you do that. Okay. Um, and yes. So basically, again, another reason why Dremio is really cool when it comes to Iceberg, specifically Iceberg Lakehouses, is its semantic layer and acceleration. These two things go hand in hand. Okay. Because one, you have a semantic layer that allows you to model your data. So again, you can see something like this, like in Dremio, where, oh, let me go back to that slide. Boop, boop, boop. There we go. Okay. So basically, in your traditional world, you would take your data sources, you would move the data to the data lakes, you would then move the data to the data warehouse, and then from the data warehouse, you'd create different data marts and then model that data. And some of that modeling may have been logical, a lot of it may have been physical, where you're creating extra copies of the data. Okay, on top of it, materialized views and BI cubes that you would then have to manage. So it can get really complicated really quick. Okay, and also really costly because again, that compute within the data warehouse is generally going to be a little bit more expensive. So it's more expensive, a little bit more complicated, all that. With Dremio, you can just connect your data sources to Dremio, and then you can create all that modeling in Dremio virtually. Okay, so basically in this case, you imagine this is like raw silver gold. Okay, so basically here, I keep changing the slides, but like in this first layer, I have like a representation of my raw data sets. Then I curate the data sets. I might join, clean up the data sets, and then I start creating different data sets for specific BI dashboards or specific reports, things like that. Okay, but these green views, like these are views, so they're logical. Okay, so there's no physical copy of the data. There is just a SQL to help it reprocess the data again. Okay, so one, you have that consistent definition. So now anyone who accesses Dremio is going to be able to see these data sets already defined, and they can do it with whatever tool they like, connect their preferred BI tool, connect their preferred notebook environment, whatnot, and have access to all these consistently defined data sets. But they can hit this feature called reflections, and they can let's say, only turn on reflections on where they need it. So if I know, hey, there's going to be a lot of people using this particular, creating data sets from this particular view, what I could do is I could turn on a reflection here. Now, what is a reflection? What a reflection does is essentially what it's doing is that Dremio is going to create an Iceberg materialization of that table or that asset. So it's essentially a Iceberg copy. Now, again, that Iceberg copy means Parquet data files, which are going to be smaller. So if you're talking about like a big, let's say CSV data set, that Parquet version of it's going to be a lot smaller, and then it's going to have Iceberg metadata on it. So you're getting the optimized physical representation, but you're also getting the metadata that acts like an index. So it's kind of like a mix between an index and a physical materialization. So you get the best of both worlds. But now what's going to happen is that unlike traditional materialized views, because in a traditional materialized view, I might have like view A, and then I create materialized view A. And now I have to go tell the analyst to go update all their queries and update their dashboard to point to materialized view A if they want to see it to perform any better. So this puts work on the analyst, and now the analyst has to be juggling which version of each table should they use for which use case. In Dremio, there would just be view A. After I turn on reflections, any new queries going to view A will be aware of the reflection, and you can actually have multiple reflections for different use cases. And it'll find which reflection is going to best serve that particular query and then substitute it. So in that case, the analyst would say, hey, this BI dashboard could be a little bit faster. Can you make it faster? I'm the data engineer. I go enable reflections, and immediately the analyst will notice the better performance on the dashboard. They won't have to adjust anything on their end. Okay, and also fairly easy to build. because you can either build a reflection using the UI with a few clicks, or you can build a reflection using SQL. But there's two kinds of reflections. There's raw, which is more like a materialized view. So you're making a copy of the actual rows of the view that you're targeting. Or there's an aggregate reflection, which is going to be more for like BI, where I'm targeting the certain dimensions and measures, and it's going to basically create an iceberg table of the pre-computed aggregations that'll be substituted when those aggregate queries come in. Okay, so now you have a query that might have taken like 11 seconds become a query that takes 1 second. Okay, I mean, there's definitely been situations where we've seen customers where, they had queries that ran for like 3 minutes and they go to like a sub-second using reflections, without them having to create too many different abstractions in the middle, they're just querying the raw data set directly from their data lake, and then Dremio, through substituting reflections, is able to give them that sub-second performance. And just makes the thinking through from the end user of, hey, what data set do I need, a lot simpler, and accelerating it. And again, it's now, why do I say, hey, if this works on any type of data, why is this so special when you have an iceberg lakehouse? Well, the thing is, these reflections do have to be updated, right? So at the end of the day, the data may change. So every once in a while, you need to refresh these reflections. For non-iceberg data sources, okay, what happens is generally it's going to be a full refresh. So it's going to rebuild it on the particular cadence you choose. So whether it's like every day or every hour or every week, you can choose a cadence and it'll rebuild that reflection. Okay, but if your data is natively an iceberg, that you get some bonuses, okay, in two forms. In the form of a feature called live reflections, which means you don't have to set a schedule. Anytime that iceberg table updates, Dremio will notice, because again, Dremio is really understands iceberg, really built around it. So it'll notice that iceberg metadata has been updated and can trigger the refresh at the moment that it's updated. So it's always going to so basically, if that table is only updated once a month, it'll only refresh once a month. But if it's updated twice a month, that month it'll get updated twice. So you don't have to worry about having the right cadence. It'll update when the table updates. But two, you get incremental updates. Because Iceberg has those snapshots, Dremio can use those snapshots to determine, okay, here's the changes from the last time the table was changed, to make sure that when it updates the reflections, it's only updating it based on the data that has changed. So you're not rebuilding the entire reflection from scratch. So that update becomes quicker and more real time. And it's also a lot cheaper, okay, because you're not running the same amount of compute to rebuild it versus just doing a quick incremental update. So you get much more bang when your data sets are an iceberg, okay? So again, really just another way that Dremio adds value specifically to Iceberg Lakehouse is really providing you sort of like the best acceleration experience with Iceberg. And now, so what this happens, okay, so let's just take a look at what the new experience is going forward. So now imagine this. Imagine that these are both iceberg tables. So these are two iceberg tables that are sitting on my data lake. Okay, I have these views that are built on them. Okay, and then what happens is I create a reflection. Let's say instead of creating the reflection here, I reflect this particular view right here. So the reflection's here. Okay, what's going to happen is that anytime either of these two tables updates, okay, it's going to trigger a rebuilding of the reflection over here. But that reflection will take a fraction of the time otherwise to refresh. And basically now, not only is that BI dashboard going to get the better performance, but if it's a data set that updates really frequently, it's going to pretty much stay in sync with it. And you get that fast performance on pretty much near real-time data. Okay, giving you sort of, and again, to do so, it's really easy because you're not, all this stuff that needs to be done to do is built in. Your data just has to be an iceberg, and Dremio takes care of the rest. You just say, hey, these are the data sets I want to accelerate. Dremio takes care of the rest. So again, it's an easier experience, a faster experience, and a cheaper experience. Cool. Okay, and this just kind of reinforces what I was talking about with like BI extracts and cubes, where they're just like a little bit more to manage. Because if you're talking about extracts, you're generally building them in each BI tool. If you're talking about cubes, they're built at the data warehouse level, but they don't generally automatically update. So you have to kind of like make sure you update them once in a while and have to worry about whether they exceed the memory of the engine. Dremio kind of, again, takes care of that all for you. It updates reflections for you. It makes sure to maintain them storage-wise. You don't have to build any pipelines to update reflections. Dremio just kind of handles all that for you. And that's sort of like the beauty of reflections. It takes a lot of the work out of acceleration and makes it where basically you just you just have to focus on modeling the data. You focus on modeling the data, and then you can just choose, hey, these are the things that need to be faster. And what's even better nowadays is that Dremio has a reflection recommender that's built in. So you don't even have to kind of think about which ones you want to reflect. Dremio will actually monitor your query activity and make recommendations saying, hey, these are the reflections you should create to speed up the queries that are coming in. And these are the reflections that you should retire because you're not using them anymore. So that way you're never using reflections you don't need, and you're always making sure you identify the reflections you do need. And that kind of movement to just trying to make things very turnkey and make it where you don't have to think about it. Dremio is continuously making more investments in that direction, where basically all you have to focus on is connecting your data to Dremio, modeling your data, and everything's just going to be fast and work and good. Okay, we're constantly trying to abstract a lot of that those intermediate steps away, so that way you can just focus on the modeling. Okay, and then the third piece is Dremio Catalog. Okay, so basically, again, to establish that we have the performance of our query engine, which allows us to run sort of the fastest queries on Iceberg data. We run pretty fast queries on any data, but on Iceberg data, definitely by far, you're going to be your fastest option. Two, the acceleration on that Iceberg data, you get, and the value you get with those live and incremental updates to that acceleration really, ups the ante for how the quality of the experience with that acceleration. And three, having that built-in catalog. So if you're using a tool like Dremio Catalog, okay, which is based on so basically the software version of Dremio Catalog is going to be built on a technology called Apache Polaris, which is a open source catalog that's being worked on by Snowflake, by Dremio, AWS, Microsoft, and Google. Everyone's at the got on that board for Apache Polaris, so you can see it's truly a industry community wide project. But basically, like any catalog, it tracks your Iceberg tables. But what's unique about Polaris is that it has two really, really cool features that are really, really important. One, external catalogs. So you have the ability not only to track multiple catalogs within your Polaris. So I can create like a catalog for my accounting team, a catalog for my sales team, and so forth. But what if I have other Iceberg catalogs that are not Polaris? Like maybe I have a Nessie catalog to use its like Git-like features. Maybe I have a Gravitino catalog, or I have a Unity catalog for Databricks work. Okay, those can then be connected to Polaris, so that way all your users, when they're consuming that data, can see all that data from one connection. Okay, so all their Iceberg tables are all visible from one catalog connection instead of managing multiple catalog connections. Okay, and that would be into Apache Polaris. And on top of that, not only do you get the catalog federation, you get governance. Okay, so the idea is that you can actually create R-backed type rules where I can say, hey, this user only has this access to the assets in this catalog. This user only has this level of access to the assets in this catalog. Making sure that you can govern your data assets, but not just in one tool, because it's at the catalog level. Any tool that connects to the catalog will honor those rules. So whether the query is being run by Snowflake or by Dremio or by any other tool, that's going to end up applying the same governance rules. So your governance, not only do the tables become portable, but the governance becomes portable. But of course, anytime you're using one of these open source solutions, the catch is you have to deploy it, manage it, all that stuff. So the beauty of Dremio Catalog is that Dremio can manage that for you. And then when you're using Dremio, it's not only managing this catalog based on this open source technology, so you can connect it to your favorite tools. So for a particular query, you don't want to use Dremio. You need to, you want to use Snowflake, you want to use Redshift, you want to use something else for a particular query on those Iceberg tables. Those tools can connect to Dremio Catalog and be able to discover your Iceberg tables from there. But on top of it, when you're working on the Dremio platform, you have all of Dremio's other federation capabilities to give you access to your databases, your data lakes, and data warehouses in one place. Okay, so now you have all your data accessible in one place. Your Iceberg tables are accessible anywhere, okay, because we're using an open catalog. It's an open platform, open to data anywhere, using open formats. And then basically you can pull in the data either through JDBC, ODBC, Aeroflight into your data workloads. Okay, so basically what happens is that now all your data is sort of governed in one place. It's all modeled in one place, and just makes your whole life simpler, because now it just does feel like one giant data warehouse. Like the experience for your end users is as if you were using a traditional data warehouse where they're just connecting to one place and seeing all their data sets. But you're doing it in a way that is open and allows you to work in the world that we do live in, where you're not going to be able to just have all your data in one place. Your data is going to end up being in multiple places, and you're still going to need to govern that data and do all these things in a consistent way, despite having a fragmented data locations. And when you're using Iceberg, data lakehouse patterns, Dremio, you're really going to get sort of the ideal experience in that world. So that kind of concludes the presentation. Okay. Basically, what I have here is several QR codes. If you want to actually try Dremio hands-on, you can scan any of these QR codes, and they'll walk you through an exercise where you can just literally spin up Dremio on your laptop and ETL some data into Iceberg and run some queries against an Iceberg table, so you can actually see what the experience feels like. This first one's gonna be the easiest one. It's just gonna spin up, just run some queries. These three right here is gonna be more end to end. So you actually spin up like a Postgres or SQL Server or Mongo database, and you're gonna ETL that data into Iceberg, and then connect that data in Iceberg and Dremio, and you're gonna connect that to Apache superset to build a BI dashboard. So you actually really see the end-to-end experience of what that looks like. Okay, so those QR codes there, and again, all these things are on the Dremio blog. Okay, also make sure to subscribe to Gnarly Data Waves. That is our regular program from Dremio. So Dremio does this regular program, and you want to make sure you don't miss any episodes of that. And again, if you've enjoyed the Data Lakehouse Lakehouse launch, make sure to join the Data Lakehouse Hub community. Okay, and you can join that by scanning this QR code. It's a Slack community. You can message me there anytime. So if you have topics you'd like to see covered during these Data Lakehouse lunches, just message them there. And with that, I'll open it up to any kind of questions anyone wants to ask. This is a calendar of events. So if you want to know which events I'm speaking at, you can subscribe to this calendar. And with that, also then post this on YouTube on the Data Lakehouse Hub's YouTube channel. But with that, I'll open it up to any questions. So if anyone has any questions, feel free to just come off mute and ask away. Okay, going once, going twice. And so, okay, so with that, that's going to wrap up our presentation for today. Go for it. Yeah, no, please do. Mm-hmm. Um, I would this I the way with the technology that exists currently, the focus would be OLAP. So, for example, like all the table formats like Delta Lake, Iceberg, Hoodie, they're all primarily built around most of the time Parquet, and Parquet is going to be really optimized for OLAP, not necessarily OLTP. Now, are there like if I were thinking about how would you do something like this for like OLTP, this is when I start thinking about projects like Terso or libsql or SQLite, where you can create more file-based transactional data and store it in different places. But um, that would be kind of a completely different use case than what the data lakehouse is trying to solve. So generally, I wouldn't think of data lakehouse as a OLTP solution, but an OLAP solution. So for analytical queries. So the idea would be I'd have my whatever I do on the OLTP side, and then I would make that accessible using data lakehouse. But I don't have to move all that data to Iceberg using a tool like Dremio. Some of that data I have in OLTP systems like Postgres or MySQL or SQL Server can still be accessible and part of that fabric. Yeah, you do. There will always be a need to kind of have two structures, just because like in OLTP you really do want the data row based versus column based. There are databases and database systems that are like hybrid in a sense, but what they're oftentimes doing is maintaining two copies of the data. So basically, to you, it feels like one system and one table, but it's maintaining a columnar and row based version of the table for you under the hood. And there's also patterns where basically, like if you like Iceberg does support Avro for like use cases like that, where maybe you initially stream the data into Iceberg. Although in practice, most people still stream in the Parquet with Iceberg. Um, so there are people trying to explore that. There's also, for example, like people have created like an Iceberg plugin for Postgres. So it allows you to like basically, you can have basically this Iceberg based piece to your Postgres database that then uses like DuckDB for querying. But I don't think there'll ever be sort of a single format where you don't end up having to copy the data twice, at least. No problem. Thank you, Harry. Mhm. Yeah, no, Dremio definitely allows you to collaborate with your OLTP data with your analytics data. Um, I mean, we've been in the federation game for quite a while, and we do have quite a variety of sources that you can connect to. And on top of that, another unique thing that's unique to Dremio, I think, basically just Dremio and Trino, is the ability to access cloud and on-prem sources. So that's another angle where basically Dremio has some unique value propositions. But yeah, no, I mean, there's people who use their OLTP data and also non SQL data with Dremio all the time. Like there's people who will literally just use Dremio so they can run SQL on NoSQL. Like they'll maybe have a bunch of Mongo databases or a bunch of Elasticsearch databases, and they put Dremio on top of it, and they can run SQL against that data. But again, we also connect to those NoSQL sources, allowing you to federate that NoSQL data with your Iceberg data. Yeah, yeah, I mean, not necessarily like. Well, there's a couple different caveats there. Okay, so first, like for Iceberg tables, there is like a Rust library, a Go library, and a Python library. So you can work. So basically, you would just connect to your catalog. So you can connect the Dremio catalog, and then operate in your tables directly without going through the Dremio compute. You would just use your own like laptop and whatever preferred language for like ad hoc jobs, stuff like that. Um, the other story is while Dremio is a SQL first engine, you can access it with with Python. I can still send SQL over to it and then get the data back as like for example, I wrote this one library called Dremio Simple Query. It's in the Python repository, and that allows you to more easily access the data in Dremio and pull it down as like a pandas or polars data frame. Another project that I would love to see a Dremio integration for someday in the future is something called Ibis. And what Ibis, and there's two projects really, Ibis and SQL Frame. And what these do is they provide sort of like a universal data frame API. So theoretically, any SQL tool, first step is they would create a dialect with another project called SQLglot for that, and then using that, you can then create a SQL frame or Ibis dialect, which means then you can write data frame like code, but then the data frame like code gets compiled into a SQL for that particular target platform. So allowing you to kind of write the queries you would be used to, and then SQL Frame specifically uses the Spark API. So in that case, you'd be writing the code like you used to writing in Spark, and it would just be compiled for Dremio or whatever engine. We generally follow ANSI. So basically, basic SQL is going to be purely ANSI SQL. The only time you really kind of go outside of that is for like unique Dremio features. So there'll be like a few like unique to Dremio commands, particularly around Iceberg. Like we have a copy into command, so you can copy to make it easier to move data from files into Iceberg and a few other commands. But basically, your standard querying is going to be ANSI SQL. Cool, no problem. And any other questions? Going once, going twice. Again, thank you everybody for coming down. If you guys had a good time, please head over to Meetup and leave like a review of the Meetup. Always like to see what you guys think. And then also, hopefully, I'll see you all at the next one, which will be listed on the Meetup page, and I'll see you guys from there. Thank you.